It turns out that there is a great benefit to understanding conceptually what's going on while learning physics and learning how to solve problems. It helps us decide equations and that sort of thing. So this video is a follow-up to the concepts of motion video. And I'm just going to go through a few questions. They're labeled quizzes. I use them in my face-to-face classes as quizzes. These questions are to test your understanding. In a face-to-face class, they also help me understand where all my students are at, if they're understanding the concepts or not. What I would like you to do is at the beginning of each quiz, when you see it come up, I'd like you to pause the video, read the question, determine what you think is the answer. That step is actually really important in your learning. So make sure you determine which one you think is the answer, and then play the video again, and I will go through the answer with you. So in this particular case, the correct answer is B. All three of these diagrams to the right are motion diagrams. The dots represent where the object is at the given moments in time. All three, the point labeled 0 means at time equals 0. So the initial moment in time that we're talking about. So in part A, because 0 is above 1, we can say that this object is moving down. It's got to be moving faster and faster and faster to cover those larger and larger distances. So A represents something moving downwards and speeding up while it does so. Well, the ball dropped from the roof of a building. That's going to speed up on the way down. And that's why A is the ball. In B, it's moving down in every situation, but because these distances are equally spaced, this is not changing speed. Something is keeping it from speeding up on the way down. So in terms of the options that we were given, the dust particle settling to the floor at a constant speed, that's why we would know that is the dust particle. And by the way, that's the one when I solve the problem, that's the one I look at first. And that allows me to narrow down a couple of the options. But it's not necessary to get that out first. In part C, we've got moving downwards, but slowing down because that distance is getting closer and closer. And that's why C is the rocket. If you have questions, please reach out to me. Send me an email in Canvas or set up a meeting time. I'm happy to help walk you through and understand better. All right, the next question. Go ahead and pause and then restart when you have decided what you think the answer is. All right, so I'm going to go ahead and draw a rough little sketch. I have a ball. Oops. I don't know what I just did. Sorry. So this ball's headed upwards. I know a ball will slow down as it goes upwards. It will eventually reach the highest point where for just a split second, V is 0. But in that time, it's turning around and then it's going to head back down, speeding up on the way down. So the velocity at the highest point, which is the point they're asking about, the velocity is 0. But the question is not about the velocity. The question is about the acceleration. Now, mind you, the most common answer is B. There's just an intuitive jump that if the velocity is 0, the acceleration must be 0 as well. But that is not the case. The correct answer here is C. Again, the definition of acceleration in physics is some change in velocity in some period of time. So we must look at 2 moments in time to be able to consider the acceleration. So if I want to consider the highest point, that's awesome. But I must also either look at just the split second before it got to the highest point or the split second after it's at the highest point. So before it's slowing down, remember, means the velocity and acceleration must be opposite. If we look at the highest point to just after, as it heads down, the velocity is going to start heading down. It was 0, it's now pointing down. The acceleration has to be in the same direction in order to make it point down. So the acceleration actually is pointing down the entire time, which, if you think about it, it's gravity, right? We can't turn off gravity. What I want you to think about, if the acceleration was 0 when the ball got to the highest point, what would the ball then continue doing? If V and A were 0 at the highest point, A being 0 means the velocity is not changing. That means the ball would hover. It would just hang out at that highest point and stay there, which would be really cool to see, but obviously not reality. So acceleration is not 0. In this particular case, it points down all the time, and simply because it is the acceleration due to gravity. All right, the next question I have for you. Go ahead and pause. And when you're ready, start again. So because they're giving us the motion diagram, notice they have the coordinate system here. This 0 right here represents the origin. They've labeled V and A, so these bottom vectors are all pointing to the left. That means whatever this particle is moving to the left. The acceleration is opposite the velocity, so the object slowing down, which of course that also was stated in the problem. But in terms of assigning positive or negative to each, again, this boils down to our coordinate system. Choosing whether position is positive or negative depends upon where the origin is located. This particle in every situation is to the right of the origin, so the position is positive. So we've ruled out E and F. Those cannot be the answer. The object is moving to the left. These velocity arrows are drawn in here. They point to the left, which means negative for velocity. The velocity is negative. So we've ruled out A and B. Acceleration, again, acceleration because the object is slowing down, which is represented with the arrows pointing in the opposite direction. To the right means positive for that acceleration. So the correct answer here is C. I believe this is the last one I have for you. Yes. Go ahead and pause and determine what your answer would be. If you think back to the motion diagrams that we drew in the concepts of motion video, like showing that something was speeding up, kept drawing those vectors longer and longer and longer and the points farther apart, the length of the arrow represents what we call the magnitude, so the number. So for example, this V1, that length is long compared to A. That means this object is moving pretty fast. This acceleration vector is pretty short. The length of it represents the numerical value. So for example, if this velocity represented, say, 10, this acceleration might be 2 or 3 in terms of comparing those lengths together. So our problem is asking us to determine the velocity vector while this object is moving down to some sort of 0.3 that is not shown in the picture. But we do know 0.3 is somewhere below 0.2. Because this acceleration vector is pointing up while the velocity vector points down, we know this object is going to slow down, this particle. And it's going to slow down by the length of that acceleration. Meaning, if I could draw A right here, whatever I have left right here would be my next velocity. So my velocity vector is getting shorter because the object's slowing down, but it's only getting shorter by this smaller amount. So the option that best fits the correct answer would be option B. You do have some conceptual questions on your homework as well. Thinking through these concepts, understanding what we mean by acceleration being positive or negative, and it not meaning speeding up versus slowing down necessarily, is really important to grasp as we move into the next chapter and look at solving problems involving motion.